In chapter 11, I have teach you on the regression analysis, and now I will show you an example how to use this regression analysis for this problem. A firm's sales for a product line during the 12 quarters for the past 3 years were given in the table below, which is this one. The firm wants to forecast each quarter of the fourth year, that is the quarter number 13, 14, 15 and 16. So now we should calculate on the forecast for the quarter number 13, 14, 15 and 16. But before we can start to do that, we need to develop the linear regression equation for this problem. So let me show you how. As we all know, the equation for linear regression is y equals to a plus bx, whereby a is the intersection of the y-axis, b is the gradient, and x is the value. Given that b is equivalent to summation of xy minus n multiplied by the mean of x multiplied by the mean of y divided by summation of x squared minus n multiplied by mean of x squared, and a is equivalent to y mean minus the b x mean. So we need to find all this value. So what we should do is that we need to develop the table. The first table that we have is the xy column, whereby the xy column is just simply y is a formula here. Okay, y the xy is equivalent to x, which is the b6 multiplied by, so you should multiply by the y and you will have the value of 600, and then what you need to do is just to copy all of them back again, and then you will have all the values calculated automatically. So below here we need to have the summation of it, whereby the summation of the quarter is from 1 until 12. Okay, and then you develop the formula is just the summation of from b6 to until b17, and then for the sales is c6 until c17 in this case. Alright, so you just copy this one to this side also. So you will have summation of d6 until d17, d6 until d17. For the x squared is just simple, okay, whereby we will use the formula of x to the power of, okay, to the power of 2. Alright, so you will have 1 here, then just copy and paste here. So you will have the x squared value, the summation also you just put it there. Okay, y squared value is just simply squaring this y value, is equivalent to y to the power of 2. Okay, so you will have this value. Alright, and then just copy it back again, and you have all the values as being given here. So next thing is that we need to search for the value of the a and b. So the value of b is being given by this formula. B is equivalent to summation of xy minus n multiplied by the mean of x multiplied by of the mean of y divided by summation of x squared minus n multiplied by the mean x squared. So we can develop a formula for this one by using this formula. B is being given by this value, whereby b is equivalent to summation of xy minus n x mean y mean divided by summation of x squared minus n x mean squared. So we can develop a formula for this one as shown in this this formula tab. Alright, so whereby the f is equals to xy. Xy is what? Xy is the value of d18 minus n. And how much is n? N is 12, from 1 until 12. Okay, so 1 until 12 multiplied by the B19, which is the mean of X. So this is the mean of X. 78 divided by 12, okay, multiply by Y mean. What is the Y mean? Y mean is this one, whereby Y mean is the C19, which is 33,350 divided by all this divided by 12. You can get this 2,779. All right, and you divide by E18, which is the E18 is the summation of the X squared minus n X mean. N is 12, okay, n is 12, multiplied by mean squared. All right, mean squared is this one, 6.5 to the power of 2. All right, so B19 to the power of 2. When you calculate, you will automatically get the value of B equals to 359.6148. As for A is equivalent to the mean of Y, which is the mean of Y is this one, the mean of Y is the C19, alright, 2779.167 minus B, which is the value that we have calculated before, which is the 359.618, this one, and multiply by the mean of X. So when you put the formula here, alright, so you can get the value of B equals to 441,667 for the 0.6667. So the formula for Y is equivalent to, we can say that Y should be, okay, Y is equivalent to A 441, okay, plus the B value. The B is 359 or 359.6, okay, in this case. All right, so sorry, A is 441.7, okay. 441.7, my mistake. All right, so do it again. 0.7 plus 359.6 multiplied by X. So you can calculate, you can use this formula in this column. Alright, so we use this one. Y is equivalent to A, which is the N16, plus B, alright, which is N14, multiplied by the value of X in this case. Alright, X is this one. So you will have a value of 801. So you just copy it all over again, then you can have the value of the Y. Sorry, so I have done a mistake here. You see, I have done a mistake whereby I need to put, since I want the value of X, A and B to be constant, I need to put a value of here, the dollar sign. So we need to put the dollar sign so that the column should maintain. So that's how it works, okay, and then we copy it again, and you will have this value given to you. Coming back to the question, because the firm wants to forecast each quarter of the fourth year, which is quarter number 13, 14, 15, and 16. So we need to put another one here, quarter number 13, quarter number 14, quarter number 15, and quarter number 16. So we need to find the value of Y. What we need to do is just to copy this one to here. Alright, so you will have this value of forecast value for Y in quarter number 13 is 5116, quarter number 14 5476, quarter number 15 5835, and quarter number 16 6195. So basically this is how to do it manually, but the thing is Excel has a very powerful powerful tool to analyze the regression. I will show you the use of the tool in the next video.